We're finding through our research that a lot of soils are biologically depleted. We're developing key products on a daily basis to help fill these voids. And as we fill these voids, we're finding out that the plants are really responding to what we're doing. What we're trying to do is bring back those key components to production agriculture. There's industry spokespeople that are saying that if we don't change our practices here in North America, we may have 60 more years of production. I'm not saying that I agree with that, but in our findings, through our research, we are seeing that the soil is depleted in certain key micronutrients, microorganisms, and fungi. As a producer, what that means is some of the inputs that we may be putting out here on our farms, we're putting them out there to try to get a return on those inputs. And we're actually limiting the amount of return, the amount of availability we're getting out of some of these nutrients that we're putting out there because we don't have the biology to support and make those soluble for uptake of the plant. What we've been led to believe in my history of working in production agriculture, that our limiting factor is actually nutrients. And so as we continue to put higher and higher levels of these nutrients, one would expect our yields to continually increase. Working on my own farm, is sometimes the more I put on actually was a detriment to my yields. So through our research, what we're finding that the biological component of your soil is really the key to yield. As I said earlier, your soil's capacity to release nutrients, your soil's biological capacity to release nutrients is really what's going to determine your yield. That's really the key factor, is your soil's biological capacity to release those nutrients. We could put extreme amounts of these macronutrients, as we all have. I know I have on my farm, but I had limited results. When we got started looking at the biological factor, that's when we really started opening some key doors. In our findings, we find out then that young plant, when it's going through that cycle of determining this is how much I'm going to produce. Now we could use a corn plant that's about 300 to 500 GDUs is when it establishes the girth of the size of the ear, the girth of the ear. And what we're finding, if we get too high nitrate level in that plant at that time, it cannot take up phosphorus. It cannot take up some of the other key elements that would really be factors in determining that ear size. So we're proponents of keeping that nitrate low in that plant early, letting that phosphorus be able to go into that plant so we can really girth up that ear and get the right size ear, or the ear that we're actually wanting to get from that corn plant.